Hello students, we at Vijeta IAS Academy are back with a new course, You Too Can, where we do what Roger Bannister has done to long distance running. On that fateful day of 6th May 1954, he ran what was thought once achievable, once impossible task of running a mile in less than 4 minutes. He achieved this stupendous task by stripping running to its basic fundamentals and seeing whether this so-called myth, which has existed since 1888, best coaches in the world, best athletes in the world have all failed from at least from 1888 in achieving this. We will do what he has done there, that is, strip a problem of its halo and bring everything to its fundamental first principles. And we will see whether it is really difficult to crack CSAT or not. And how are we going to do this? This way. We are of a belief that any CSAT question, especially those years where people feel them difficult, after 2020, 21, 22, 23, are solvable under a minute. Don't believe us? Follow us. What we do in this is one approach. We see a question, instead of rushing when you see a question to solve, we will see what is the question asking for and where is the weakness point, or what is the most efficient way to solve the question, and next we will see the principles involved. This is where we will get our hands dirty and see, is really CSAT that difficult based on the principles involved. Let's get down to it. Choose the group which is different from others. What do you see? At the first instant you get that all are odd numbers. What are the various categories that odd numbers have? Either they are prime or they are composite. Odd, even, prime, composite. I think these are the first few minutes of any number systems class, irrespective of a coaching center. And what they have asked? Just on primes. If you know primes below 100, what do you see? This is 13 into 7, 91. Rest all are prime numbers. How much time does it take? Hardly less than 1 minute. This is, once you see it, you will immediately catch on to the answer. So, the principle checked here is prime, which is almost the basic of any number system class, no matter whatever the coaching center. They start with prime numbers, composite numbers, even numbers, odd numbers. Okay, next. Let's see one more. There is an operation that is happening between all these digits and we get this resultant. How many operations are there? What are the basic principles involved here? Mathematical operations, that which we have been doing since our LKG or UKG. Okay. What are the 4 mathematical operations? Plus, minus, multiplication and division. Can this be plus? No. Why? Because in addition, always if you add 2 numbers, the resultant will always be greater than the digits you are adding it. So, this can't be addition. Can this be subtraction? Possibly no. Because all these numbers are close enough to each other. You can't get a number this high when numbers are this close. Suppose 9 minus 10 minus 9 is 1. So when numbers are this close, the difference is less, but difference here the answer is almost comparable, so it can't be this. Can it be multiplication? It is too small for even 2 digits, and we are thinking of doing the same operation for 3 digits, so it is not possible here too. And division, none of the numbers are particularly either multiples or factors. So what we do? It must be some of the other this thing which is derived from these basic things. So what you do basic, you know addition, just do that first. Even without knowing the answer, taking a step forward in the right direction is as important, because either you will know that that is the way, or you will know that this is not the way. Your one of the option decreases. Let's go with addition here. 7 plus 9 is 16. 16 plus 10 is 26. Once you see this, compare with this digit. What is this? This is nothing but addition of the digits. 2 plus 6 is 8. Let's go here now. 9 plus 11, 20. 20 plus 30, 50. 5 plus 0, 5. You got it. Just adding 3 digits. How much time will it take? It is less than 1 minute. Now, what is the answer here? 23 plus 4 becomes 27. 27 plus 15 is 42. 4 plus 2 gives 6. How much time does it take? Hardly 1 minute. And what are the principles that UPSC checked here? Simple, basic operations. Those things which we have been doing since our kindergarten. Next. Let x be a positive integer such that 7x plus 96 is divisible by x. So again, what are the principles involved? Division. 7x plus 96 by x. What is he telling? He is telling that this x is dividing this number. Okay. Now, break this number into its fractions. 7x by into component parts. 7x by x plus 96 by x. This is already divisible. Now we need to see what are the numbers where all we need to see is factors of 96. Because what are factors? Factors are those numbers which divide a particular number. So if x divides 96, this gives us an integer, and he has given that it is divisible by x. That means we need to see how many factors of 96 are there. Divide 96 into its prime factors. Let's take 48 into 2. Go a step further and 48 becomes 16 into 3 into 2. 16 is nothing but 2 to the power of 4. So the final this thing is 2 to the power of 5 into 3. What is the formula for factors? If after prime factorization you get x to the power of a plus y to the power of b, the number of factors are a plus 1 into b plus 1. Okay. Now 5 and 1 here. So 5 plus 1 into 1 plus 1. So 6 into 2, 12. How much time does it take after knowing this formula? This is one of the first fundamental formulas that anybody, irrespective of the coaching center or irrespective of anybody who deals with number system, they go through it through factors. So the principle checked is factors. What is your LCM? What is your HCF? Highest common factor. Factor again. Any complex principle, is UPSC checking you on any complex principle? No. In the first problem, it was in the first question. Now, In the first question it was prime numbers. In the second question it was mathematical operations, which we have been doing since our childhood. In the third question it is factors, LCM, HCF, since our childhood again. Now, P, Q, R and S are distinct single digit positive numbers. Then what is their greatest value? What would be the answer here? Principles. What are the principles involved? Optimization. Now you see why attack point is important. They have asked us for the greatest value. For the greatest value to be present, the digits involved should be great. Am I right? Suppose you do 2 plus 1, which becomes 3. You increase the digit to 3, 3 plus 1, your result obviously increases. So for the greatest value to be there, the digits have to be their greatest. What are the greatest digits we will have? Okay, let us go again. He asked for PQRS are distinct single digit positive numbers. Then what is their greatest value? What is your attack point? Greatest value. Now for the value to be great, constituent digits have to be great. For example, if you add 2 plus 0, the result is 2. If you add 3 plus 0, the result is 3. If you add 3 plus 1, the result is 4. So for maximum value, you need maximum constituent digits. So what are the greatest constituent digits we will have? 0, 1, 2, 3, 4, 5, 6, so on and so forth, 7, 8 and 9. We need 4 digits. What are the maximum 4 digits? This. Okay. Now we have got the digits, but what is he asking for? The greatest value. So we know the digits. Now clear this off. A simple principle. Whenever the sum is constant, see its multiplication. Suppose sum of two numbers is a constant 6. We will see how multiplication varies. 6 can be written as 6 plus 0. Okay, the multiplication is 0. It can be written as 5 plus 1. The multiplication is 5. Next, 4 plus 2, 8. 3 plus 3, 9. And again you will repeat this. 2 plus 4. It is nothing but repetition of previous case. So what do you observe from this? Take an example. Even if you don't understand this thing, he just wants you to find the greatest value. Once you know the attack point, that this greatest value, you will obviously come here. Now see, for the product to be maximum, the constant digits should be as near as possible. Okay. Now how do you make this as near as possible? One big guy is there, one small guy is there. How do you equalize that? Mix a big guy and a small guy together. Same here, 7 plus 8. They are almost similar. So 15. 15 square is 225. Even if you don't know all of this, we know that maximum of a product occurs when constituent digits are equal. So when he asks for a product, the maximum product can be a square. Observe which number is square here. 230 is not a square, 225 is a 15 square, this is not, this is not. If you know where to attack and which points to see, hardly. 15 square is 225. The principles checked are here. squares. Again, those things which I have learned from our childhood. Next, optimization. This is just, there is nothing complex here. Even if you take 6 plus 0 and 5 plus 1, you will know that for the maximum value, products has to be, the constituent digits have to be as near as possible. Just apply this. You will get here only when you find out the attack point is this greatest value, and your answer flows from this. So, just like in the first question, it was either first question it was primes, in second question it was basic mathematical operations like addition, subtraction, here squares. Where is the complexity in this? It is because we are making it complex. Next. I mean, people literally freak out when they see bigger numbers like this. But what has he asked? I am assuming that everybody knows division at this time. Suppose a number is there. 2 into 4 into 6 into 8 by 2 into 6. What happens? Even an LKG guy will tell you that 2 and 6 cancelled. Okay. Now, what he asked? He asked us the remainder. Remainder is you divide it by 100. So 85 into 87 into this number is given. What we need is, if all the constituent digits which make up all the factors of 100 go divide any of these numbers. Okay. How do you divide 100? 100 is nothing but 4 into 25. 4 is nothing but 2 square into 5 square. So, for the resultant remainder to be 0, all you need to see in this is 2 2s and 2 5s. 5 gone, 5 gone. This is 24 4s. 2 2s are already present here. Done. How much time does it take? This is just cancellation. What are the principles involved? Division and then cancellation. Every person who has gone through basic schooling will know this principle. The problem is we are unable to apply the principle here. That's why it is seeming difficult. How much time will you take for cancelling out 2 2s and 2 5s? Hardly 30 seconds, less than 1 minute. In the same way, in the series, we will strip down all CSAT 2023 questions. And we will find out, is it really CSAT something to be feared or something to be enjoyed solving? Because I literally enjoyed solving all this, because all you need is find an attack point and the answer appears right in front of you without no possible calculations, no complex multiplications to be done. What are the basic principles checked? In the first it was prime numbers, in second it was mathematical operations, plus, minus and all. In the third, here it is again division. In the third it is just one optimization problem, which you can get even just thinking for 2 seconds before applying the question. He is asking us the greatest in the third question. He asked us for the greatest thing. So, fix your attack point as the greatest digit, and from there your answer easily flows. And even if you want to be street smart, there is only one answer, which is a perfect square. You can choose that. CSAT is simple, believe us. If you are not convinced by this, everybody had a feeling that CSAT 2023 number system questions are difficult. In our next video, we will take those problems which everybody felt difficult and we are going to solve under 15 minutes and see. In the same way, we are going to strip every problem to its basic principle asked. And because I have done this, I have found that all the questions that they framed on are nothing but those principles which we have been doing since our kindergarten. It is that easy. CSAT is easy, believe me. Meet you in the next class. Shashi.